Hello, I am Ravi, going to present my research proposal on the topic inter-Docker cluster communication across different network regions using e. Cloud computing has become a revolutionary technology in this era. The key enabler technology in cloud computing is virtualization. Virtualization creates virtual machine instances used for computation in cloud. Docker container is the new trend which is replacing virtual machine in virtualization. The communication between two Dockers is required for providing aggregated service hosted on different Docker clusters. Inter-Docker communication provides fault tolerance and high availability. However, the problem in inter-Docker communication is latency and VLAN on overlay network. Now we are going to discuss the literature review in which we had compared 8 research papers. The first paper we have considered is denial of service attack on Docker. The author proposes pragmatic solution for DOS attacks on Docker, but the author has only covered DOS attack and REST attacks have been ignored. The second paper is network virtualization by Docker agent. The author proposes SDN controller platform based on Docker engine for network virtualization. The paper covers only routing modules of SDN controller. Rest modules have been ignored. The third paper is Docker-based distributed cloud monitoring. The author proposes distributed cloud monitoring using Docker for cloud services monitoring. The research work doesn't cover fault tolerance capability. The fourth paper is Docker container optimization. The author proposes energy-aware scaling algorithm and system for Docker container optimization. The research work has only considered a scenario taken for creation of multiple Docker containers on single system, but multiple system scenario has been ignored. The fifth paper is Dynamic CPU Scheduler for Docker. The author proposes FDS scheduler for dynamic scheduling of Docker container. Scenarios such as no availability of CPU on physical system has been ignored in this paper. The sixth paper is Emergency Communication System with Docker. The author proposes an application to establish low-cost emergency communication system using Docker for natural disaster victims. Docker system failure hadn't been covered in this paper. The seventh paper is Honeyspot systems based on Docker. The author proposes honeypot infrastructure based on Docker for security evaluation. The research work describes best security practices but doesn't mitigate the vulnerabilities detected in the experiment. The eighth paper is Docker based distributed software development tool. The author proposes virtual system of systems SOS for distributed software development process on multiple clouds. The infrastructure is created on a single physical device which can lead to single point of failure, and it is not addressed in this research work. Now we are going to compare the all research work. In this, the comparison table provides the different features provided by the research work done. Such as the first paper, denial of service attack on Docker, provides security features but lacks performance, automation monitoring, and the most important, inter-Docker communication. Similarly, all the paper's features had been described in this paper. Now we move to our solution. First is the activity diagram of the solution, which describes the scenario is like the user request for a new service or an existing service to the provider. The admin either requests the service or denies the service. If the requested service is accepted, it starts the Docker service and configure the resources. Then the Docker starts communicating with each other, and the output is generated, which is further delivered to the user. Now we move to the technical architecture of the solution. In this uh, architecture, in geographical area 1, Docker hosted on physical device forwards the packet to the access switch, which further forwards to the core switch. The core switch acts as a VTEP and encapsulates the frame into VXLAN packets. The packets are forwarded to the router, where it is encapsulated by the EVPN and moved on the network. The packet reaches to if other side of the network, that is the geographical area 2. The packet gets de-encapsulated and similarly by the router and then by core switch and reaches to the Docker. Now comparison of our research work. Our research work provides communication features and lack the rest of the features such as performance, security, automation and monitoring, as it was not part of the goal. Now we move to the conclusion and perspectives. No research work done till date to take into account inter-Docker communication. Our eVPN solution serves the goal. Existing research work solutions can be integrated with our architecture without any conflicts. The future work can be performed into two directions. First direction can be comparison with other technologies such as inter-VM communication, and the second direction can be adding more values or features in eVPN. Thank you.